I prepared a first draft construction schedule for the pollution-free city I designed. It goes month by month and task by task, inspired by the project templates I was trained to build and use in the Corps of Engineers. After practice with the Corps of Engineers software on multi-million-dollar and billion-dollar projects on the state and national scales, involving thousands of activities and interrelated tasks, I became ready to handle the schedule building for multi-billion-dollar projects, such as those building entire neighborhoods and the city. Like most construction projects, you travel out to inspect and survey the land first. Once you know what the soil and bedrock are doing, you know how to anchor the buildings down into them. You also check the water tables, radon potential, and for evidence of any ancient ruins or dinosaur bones, among other things. When all of that is clear, you enter the design phase, which is preceded by the planning and analysis phases, and followed by the build, test and commission, and maintenance phases. This is what brings us to the construction schedule of Innisfree. Its construction schedule is part of its design because it uses some very clever tech to come to life. The more drones, 3D printers, and TBMs, that's tunnel boring machines, which we use to build the city I designed, the faster its build will go, the whole thing being possible within just 1 year. Yes, it can take 1 year to build an entire city, provided many 3D printers and other cutting-edge tech are used. Each 3D printer can print an entire house in 1 day. Industrial scale printers can now print the pieces for skyscrapers, having them assembled in just a few weeks. Now imagine multiple printers working at the same time, each making a house in a day or less, and all of them being moved from foundation to foundation at the same time. The result being entire neighborhoods and downtown areas springing up every week, completed every month. We will also have printers printing pieces for more 3D printers. So we have an exponential increase in the number of printers we have on site the whole time, and an exponential increase in how many homes and other buildings are being erected. At the end of 12 months of this, we'll have thousands of printers and other printed devices, all wrapping up in their various areas across Innisfree's 100 square miles of surface and subsurface terrain. Each of those areas linked by the highways and subways put together, just like the buildings were. And all of the printers that we shipped and made will stay in the buildings they finish printing, allowing us to print replacement parts and repair tools for them as needed for as long as they are meant to stand. Here you can see one of the skyscrapers China was able to 3D print the pieces for, allowing for a much faster assembly and inspection. The result was that all construction schedule records had been broken. What used to take years to complete, China, with 3D printing, proved able to complete within weeks. This was one of many 3D printing breakthroughs, as well as breakthroughs in general, all of which the team making Innisfree has put to work for us. 3D printing using light, oxygen adjustment, and even signals such as music-like sound sequences are making the printing, assembly, inspection, fine-tuning, repair, and maintenance processes much faster as well. In the very near future, we will see 3D printing on site, no longer limited to warehouses or factories with stationary 3D printers and vehicles that can either drop off 3D printers such as by helicopter crane or function as the printer platforms themselves, and 3D printers that become part of the buildings they print, such as printers that print 3D printer warehouses and factories around themselves, then continuing on to print house and skyscraper component-sized products from those buildings they made.